Hello and welcome to Algebra 2, Lesson 65. In this lesson, we're going to learn about graphing parabolas. So up to this point, we've only graphed lines. As we move forward in math, we must be prepared to deal with more complex shapes. So the focus of today's lesson is to learn about something known as parabolas. Now, first and foremost, the graph of any quadratic function, or you could say the graph of any quadratic equation, is known as a parabola. So what we're going to start out today with is this f of x equals x squared. If this is generally what you're going to see in your textbook or in your class, this is going to be the first parabola you deal with, and it's what we're going to use as a comparison when we're talking about shifts. Okay, and we're going to get to that in a second. So what you'll notice about a parabola is that the shape kind of looks like a U. But depending on the function that you're given, this guy could be skinnier, it could be wider, it can open up as it does here, or it might also open down. We're going to see examples of these not only in this lesson, but in the next lesson where we continue talking about parabolas. Now, this function is already graphed for us, and you might say, well, why is that the case? Well, we aren't really going to talk too much about how to sketch the graph of a parabola. At this point, the process of graphing is pretty straightforward. You gather some points, you plot them, and then you sketch. The one thing I want you to know is that the process of graphing something that's not linear is a little bit more difficult. You're going to be less accurate, and generally, if you want something that's going to be accurate, you either need to use a graphing calculator or some type of graphing software. So to eliminate the inaccuracies, I just have the curve already sketched for us, and we can go through and get some points going just so it kind of feels like we're completing the full process. So if we had f of x equals x squared, and we wanted to sketch the graph, we'd get some points going. So let's just start with x equaling -2. So if I plugged in a -2 for x, I would square it, I would get +4. Then let's do x equals, -1. Plug in a -1 for x, square it, I get 1. Then let's do x equals 0. Square 0, you get 0. Then let's do x equals 1. Square 1, you get 1. And then lastly, let's get x equals 2. Square 2, and you get 4. So we could plot these points. So -2 comma 4. So -2, 4. That's right there. Then -1, 1. So -1, 1. Then 0, 0. So 0, 0, or the origin. Then 1 comma 1. So 1 comma 1. And then 2 comma 4. So 2 comma 4. You can see where we plotted our points. And again, if you were sketching this freehand, you'd have to get a lot of points kind of going this way to really get this thing accurate. So as you move forward, you really want to start relying on graphing calculators and graphing software. I realize that in some classes, they're going to make you sketch some graphs. It's okay. Your teacher's going to understand that it's not going to be 100% accurate. Okay, so now that we have the general idea of what a parabola is, let's talk about a few important things. So the first vocabulary word that you're going to encounter is that of a vertex. So the vertex, and let me highlight that, is the lowest or highest point on our graph. So if we have a parabola that opens up, like in the example we saw, the vertex is the lowest point on the graph. So in this case, it's here. If we have a parabola that opens down, which we'll see at the end of the lesson, it's going to be the highest point on the graph. So one other quick point I want to make about parabolas, a parabola is symmetric about its axis. This just means we could fold our graph and the two curves would coincide. So you can imagine taking this y-axis here and just drawing a line down there. I know that's not perfectly straight. If you folded the two curves, you could see that they would coincide. So that's what they're talking about there. So now let's talk about shifts. And this is the first thing you're going to come to when you start talking about parabolas. So we've seen the graph of f of x equals x squared. So the question is going to be, how can we use this to graph something like f of x equals x squared plus 3? Well, without looking at the graph, let's just do some points for each one. So we saw the points for this one. We know it's -2 and then 4, -1 and then 1, 0 and then 0, 1 and then 1, and then 2 and then 4. So let's use the same x values and see what we get for f of x or y values. If I had a -2 plugged in for x, what would be the result for y or f of x? Well, it's going to be the same thing as here. It's just going to be 3 units higher, right? Because I'm taking this and then I'm just adding 3. So I can just take this right here, 4, and say 4 plus 3 would give me 7. Or I could manually do it. Negative 2 squared is 4. 4 plus 3 again is 7. So I can just take all these values and I can just add 3 to the y or f of x values. So negative 1 would correspond to a y value of 4. 0 would correspond to a y value of 3. 1 would correspond to a y value of 4. And then 2 would correspond to a y value of 7. Again, all I'm doing is I'm taking the result from here and I'm just adding that 3 to it. Now, what do you think that does in terms of the graph? Well, for the same x value, my y value in every case has been increased by 3. So that's going to create a vertical shift up by 3 units. And you can see this graphically. So this is the original. This guy right here is f of x is equal to x squared. We see the vertex occurs at 0, 0. We saw this. We talked about it already. This guy right here is the graph of f of x is equal to x squared plus 3. The vertex, or the lowest point, occurs here at 0, 3. Everything has just been shifted up by 3 units. So the vertex went up 3 units. If you took a point like 1, 1, which is right here, if that shifted up 3 units, then that now occurs at 1, 4. Let's take a look at another example. So again, you have this f of x equals x squared. Now we're going to look at f of x equals x squared minus 1. Some of you can already guess that this will be a vertical shift down of 1 unit, right? Because you have this minus 1 here. So the y values will just be decreased by 1 unit. So in other words, if I go through here and say negative 2, negative 1, 0, 1, and 2, we remember this is 4, this is 1, 0, 1, and 4. I can copy this, so negative 2, negative 1, 0, 1, and 2. All I'm going to do is take these y values and I'm going to decrease them by 1. Because I'm plugging it into the same thing. The only difference is that minus 1 at the end. So I plug in a negative 2, I square it, I get 4. I take away 1, I get 3. So this is 1 less, so minus 1. This right here wouldn't be 1, it would be 0. 1 less. This 0 would be negative 1. This 1 would be 0. And this 4 would be 3. So for the same x value, the y value is 1 less. So this is a vertical shift of 1 unit down. And you can see that here. So again, this is the original. This is f of x is equal to x squared. And then this guy right here is your f of x is equal to x squared minus 1. It's a vertical shift down. Here's your vertex at the origin, 0, 0. On the next equation, where we have f of x equals x squared minus 1, the vertex moves down 1 unit. So it's at 0, negative 1. Again, if I pick a point like 1, 1, which occurs on the original, f of x equals x squared, if I have an x value of 1 here in this equation, it goes down by 1 unit for the y. So that's going to be right here. So just shifted down by 1 unit. Okay, so pretty easy to understand that one. So generically, when working with parabolas, if you have f of x equals x squared plus k, okay, so plus k. We know what f of x equals x squared looks like. We're adding this k to it. So this will be shifted up k units if k is greater than 0. So we saw that when we had f of x equals x squared plus 3. It was shifted up 3 units. Then down the absolute value of k units if k is less than 0. So when we had x squared minus 1, we think about that as plus negative 1. We're really saying the absolute value of negative 1 is 1, so we're shifting it down 1 unit. Right? We just saw that. So this is what you want to write down and kind of commit to memory. Right? If you're working with f of x equals x squared plus k, your vertical shift will be up if k is greater than 0 or down if k is less than 0. Right? So if I had f of x equals x squared plus 10, I know that's a vertical shift of 10 units up. If I had f of x equals x squared minus 30, I know that's a vertical shift of 30 units down. So very, very easy once you understand what's going on. That's a typical question you'll get on a test. All right, so just some more kind of information. The vertex for a function of the form f of x equals x squared plus k is going to occur at 0, k. So you're thinking about the lowest point here. Well, if I plugged in a 0 for x, 0 squared would give me 0. I would be left with f of x, or you can think about that as y, is equal to k. So 0 is the x location, k would be your y location, or your f of x location. All right, so now that we talked about the easier scenario, which are vertical shifts, let's move on to horizontal shifts. Now, these might give you a little trouble mentally, but again, it's like anything else. Once you kind of get used to it, it's really not that bad. So we have f of x equals x squared, and what we're going to compare this to, we have f of x equals x minus 1 squared. So let's just think about this, and again, this is something that really gives students a lot of trouble. Let's say I started with my typical -2. -2 squared, we know that's 4. And then -1, -1 squared is 1. 0, 0 squared is 0. 1, 1 squared is 1. And then 2, 2 squared is 4. When we think about points for this guy right here, if I had a -2 plugged in for x, what would happen to y? Well, I plug in a -2. -2 minus 1 would be -3. -3 squared would be 9. Okay, so you say, well, I don't really see what happened. Okay, so let's keep going. So you plug in a -1. -1 minus 1 would be -2. -2 squared would be 4. So -1, and then you'd have 4. If I plugged in a 0, 0 minus 1 would be -1. -1 squared would be 1. If I plugged in a 1, 1 minus 1 would be 0. 0 squared is 0. And then if I plugged in a 2, 2 minus 1 would be 1. 1 squared is 1. So what's going on here? Well, what's going on is that the x value must be 1 unit larger to obtain the same y value. This is going to create a horizontal shift to the right by 1 unit. Because again, let's just think about this. The x value needs to move 1 unit to the right or be 1 unit larger to obtain the same y value. So just if we take a look at the points, an x value of -2 corresponds to a y value of 4. An x value of -2 corresponds to a y value of 4. Here, I've got to increase the x value by 1, or go from -2 to -1 to get a y value of 4. So I've got the same y value here and here, but my x value increased when I went to this guy by 1. All right, I went from -2 to -1. So again, that's what's going to create this horizontal shift to the right, okay, by 1 unit. It's because to get the same y value, or to be in the same vertical location, I've got to move to the right by 1 unit. So here you can see the two graphs on the same coordinate plane. This blue guy right here, that's our f of x equals x squared. And this green guy right here, this is f of x is equal to the quantity x minus 1 squared. And again, all this is a horizontal shift to the right by 1 unit. For this guy, the vertex occurs at 0, 0. So for this guy, I'm just going to shift to the right by 1 unit. So the vertex occurs at 1, 0. Okay, so everything is to the right by 1 unit. So again, if I look at a point like 1, 1, this is moved 1 unit to the right. So now I'd have an x value of 2 with a y value of 1. If I have an x value of 2, that corresponds to a y value of 4 for f of x equals x squared. For this guy, I now need an x value of 3 to correspond with a y value of 4. So again, I'm just shifting everything to the right by 1 unit. All right, let's take a look at another example of this horizontal shift. So we have f of x equals x squared again. You're always going to see that. And we're comparing this to f of x equals the quantity x plus 2 squared. So now we're adding 2 to x. So think about this. This is going to go in the opposite direction now. The way you want to think about it is that the x value must now be 2 units smaller to obtain the same y value. Okay, 2 units smaller. And we can just do some points to see that. So again, we go with our -2, -1, 0, 1, and 2. You probably memorized this by now. This is going to be 4. This is going to be 1, 0, 1, and 4. All right, so let's use the same x values over here. So we'd have -2, -1, 0, 1, and 2. So -2 plus 2 would be 0. 0 squared is 0. Then -1 plus 2 would be 1. 1 squared is 1. 0 plus 2 is 2. 2 squared is 4. 1 plus 2 is 3. 3 squared is 9. And then 2 plus 2 is 4. 4 squared is 16. Now again, when I look at this here, let's just take 0, 4 as an example. I have an x value here of 0 that corresponds to a y value of 4. Here, when I have a y value of 4, I'm thinking about an x value of 2. So 2, 4. So in other words, this guy right here, this 0, is 2 units less than this 2 here. 2 units less in terms of x, we're moving 2 units to the left on the x-axis to get to that same y value of 4. And you can see it when you look at the graph. So here's your vertex here for, again, f of x equals x squared. And then here's your vertex for f of x is equal to the quantity x plus 2 squared. You can see everything is just shifted 2 units to the left. Here it's at 0, 0. Here it's at -2, 0. So my x location just went 2 units to the left or decreased by 2. You can think about this point 1, 1 that we keep going to. Well, if I decrease my x value by 2, so I go 1, 2 units to the left, I know that I'm going to have my y value of 1. You can see that there. If I take a point like 2, 4, that's here. If I decrease my x value by 2, and I go from 2 to 0, I'm going to see 0, 4, right? So the same y location occurs when the x value is 2 units left or 2 units less. So this is what's creating the horizontal shift. All right, so here's the kind of cheat sheet for this. When working with parabolas, again, if you see f of x is equal to the quantity x minus h, and this is squared, this will be shifted h units to the right if h is greater than 0. Okay, h units to the right. So if it's x minus 1, then it's going to shift 1 unit to the right. Because again, the x value needs to be 1 unit larger to obtain the same y value. So that's what creates that shift. Then the other scenario, we say the absolute value of h units left if h is less than 0. So this gets a little bit tricky. You're thinking about things like, let's say you saw the quantity x plus 3 in there. Well, really, I could write this as f of x is equal to the quantity x minus a -3, right? Because we're always keeping that minus symbol in there. So this is squared. But if you see plus 3, you know that you're just going to move left by 3 units, okay? You don't need to go through all this. Really what this is technically saying is that you take the -3, you take the absolute value of that, you get 3. You're going to move 3 units left. But again, this is ultra complicated. When you see a minus sign and a positive number behind it, you know you're moving right by that number of units. When you see a plus sign and a positive number, so like x plus 3, for example, you know you're going to move left by 3 units. So the vertex for a function of this form, if we have f of x equals the quantity x minus h squared, this is going to occur at h, 0. So in other words, if I plug in an h here for x, that's going to be h minus h, which is 0. 0 squared is 0. So that's giving me the lowest point for y or for f of x, so the lowest point for the function. All right, so if you're on a test and you're really, really confused, you don't know what's going on, horizontal shifts give students the most trouble. You can kind of go through it, and with the vertical shifts, they really get it right away. But a lot of students with the horizontal shifts are just like, I don't know what's going on. I can't figure this out. Just find the value that causes x minus h to be 0. This will give you the shift. So if it's, let's say I had f of x is equal to the quantity x minus 30 squared. What would make this equal to 0? Well, if I just plugged in a 30 for x, 30 minus 30 would give me 0. 0 squared would be 0. So if I'm plugging in a positive 30, you think about positive as moving right? So I'm moving right 30 units. So it's a 30 unit to the right shift. Horizontal shift to the right 30 units. However you want to think about that. If I replace this with 25, we know the shift would be 25 units to the right because I'd plug in a 25 in for x and I would get a 0 there. If I change this to a positive, let's say a positive 7, how can I make this 0? We'll plug in a negative 7 for x. Negative 7 plus 7 is 0. So you think about negative as moving to the left, a negative direction. So I'm shifting to the left 7 units. So this is a little trick. It's not something to confuse you. If you're lost when you're talking about horizontal shifts, just find the value that causes the quantity x minus h to be 0. Okay, so forget about the squared, forget about the f of x, forget about the notation. What would cause this to be 0? Give that answer, and you've found your shift. If it's negative, you're moving to the left. If it's positive, you're moving to the right. So here I'd need a negative 7 for x, so I'm moving to the left 7 units. If this was plus 89, I would need to put a negative 89 in there, so I'm shifting 89 units to the left, right? So on and so forth. So in tougher examples, we combine a vertical and horizontal shift. So you'll see these examples where you see f of x equals the quantity x minus 2 squared, then plus 3. So some of you get it right away. You just combine the two shifts. So if I think about the horizontal shift, I just look at this and I say, okay, I have a negative 2 there, a minus 2. I know that corresponds to a shift to the right. So a shift to the right by 2 units. Then this plus 3 here is a shift up by 3 units. So a shift up by 3 units. So this guy would shift, so it shifts right 2 units and up 3 units. Okay, pretty easy overall. So you can see this graphically. Again, this is the original f of x equals x squared. And then this guy right here is f of x is equal to, we have the quantity x minus 2 squared and then plus 3. So here's your vertex, here's your vertex. So that's what I look at. And you just think about the fact that, okay, it's a shift of 2 units to the right. So I'd go 1, 2 units to the right, and then 3 units up. So 1, 2, 3 units up. So you go from there to there. So 2 units to the right, 3 units up. This is all you really need to do on your test, especially if it's presented to you in a graph. You can just count the shift to the right or the shift to the left, and then count the shift up and down, right? So very, very easy to do if you get it on a graph. So when we see the format f of x equals a times the quantity x minus h squared plus k, where again, a does not equal 0, we can say the vertex occurs at h comma k. And why is that the case? Let's go back up. We're thinking about how to make this, in this case because this is positive, as low as possible. So if I plugged in an h for x, h minus h would give me 0. 0 squared is 0. 0 times a is 0. So this is essentially gone. So I'm just left with k. Right? So that's the lowest it can be. Plug in an h for x. That eliminates that. It wipes it out. I'm just left with k. So that's why our vertex occurs at h comma k. Then we have a vertical line of x equals h as its axis. Again, that's going to split it in half. If you fold on that, the two curves are going to coincide. And then the graph opens up if a is greater than 0, right? If a, the coefficient of the squared variable, is positive, and it's going to open down if a is less than 0, or again, the coefficient of the squared variable is negative. All right, so overall, not too difficult, just things you need to get used to. A lot of it is just memorizing what you need to do. And then as we move forward, we're going to start seeing some downward-facing parabolas. So all we've seen so far are the parabolas that open up. So the f of x equals x squared, that variety. Now we're going to look at f of x equals negative x squared. So the trick here is that if you have a negative coefficient on the squared variable, so you're going to have a parabola that opens down. So a downward-facing u. So now if you think about the vertex, it's going to be the highest point. Right, so this 0, 0 here is the lowest point for the upward-facing parabola, but the highest point for the downward-facing parabola, okay? And as you move higher in math, you're going to start talking about these as minimums and maximums, but again, we'll get to that later on.